Today we will continue solving problems from exercise set 1.2. Complete the statements. The symbol, this one, means greater than. Well, it's not or equal because the equal sign is missing. Like in second case here, we have this symbol which also involves an equal sign. So this one will be less than or equal. If A is less than B and B is less than C, then A is less than C. This property is called the transitive property. If both sides of an inequality are multiplied by a number, the direction of the inequality remains the same. If both sides of an inequality are multiplied by a number, the direction of inequality remains the same. Well, that number must be a positive number. If both sides of an inequality are multiplied by a number, the direction of the inequality must be reversed. Well, it must be a negative. And what is a statement indicating that two quantities are not necessarily equal inequality. Alright, let's continue to the second exercise. Graph each inequality on a number line. Well, let's try to show them here. If we have a number line like this, and this is the number -2, now x being -2 means all these numbers, just to not get confused between these two rows, I will show it here, like all these numbers here, except the number -2. So to show that there, we need to leave it empty, like here. So all the numbers except the number -2. Under B, we have x greater than 2. So we have the number 2. All the values here are greater than 2. How do we show that? Well, we can show it something like that. This black part, it should be empty here. So all the numbers from 2 to the right side. Same goes for C, but with an opposite direction. We have the fraction 1/2 here. So all numbers that are less than but not equal, so we'll leave it empty there. But under D, we have again the same case. We have x is greater than 5/3. So what do we have? All these values that are represented from 5/3 to the right side without including 5/3. So we'll leave the circle empty. Now let's see, we have x from -3 to infinity, but also involving -3. So that means less than or equal. So this region, but now we have to fill this dot here. So everything is included, like including the number -3. Then what do we have? X greater than -4. But also it includes -4 itself. So all the numbers from here to the right side. Under G, we do have something like this, from 3/5, all numbers up to 3/5, including 3/5. So that means all these numbers to the left side, including 3/5. Next, we get all numbers up to 0.25, including 0.25. And then we do have, now if you try directly to represent this inequality on the number line, it would be kind of difficult because it's not x. So what do? We want to multiply here by, -1. So what do we get? We get -4 is greater than or equal to x because it switched direction. So what do we get now? Well, we have x should be less than x should be less than negative 4. So again, we have negative 4 here, and x should be less than negative 4. Also, it can be equal to negative 4. Alright, under j we have same situation. We multiply both sides by negative 1, so we get x is greater than or equal to 3. And represented in a number line, it would be something like this. X is greater than 3, so from here and on, also including 3. And the last one under k, we multiply again both sides by negative 1, and we get x less than or equal to negative 1. And represented on a number line, it would look something like this. Right? Also, negative 1 is included. Let's continue to exercise 2. Graph the solution set of each inequality on a number line. Let's continue with the first one. So what do we have? We have x plus 2 is greater than 4. Subtract 2 from both sides, we get x is greater than 2. This solution represented on the number line. Let's draw the number line first. What do we have? The number 2 is here, and the solution is all x is greater than 2. Well, it's not including 2, so it will be an empty circle. Under b, we have x plus 3. Under b, we have x plus 3 is greater than or equal to 6. Same, we will subtract 3, so x is greater than or equal to 3. Represented on the number line, let's say the number 3 will be somewhere here. X is greater than, but also it can be equal, so it should be filled there. Under C, we have x plus 5 is greater than or equal to negative 1. Let's subtract 5, so x is negative 1 minus 5, it's negative 6. Again, represented on the number line, negative 6 is somewhere here, so x would be all values of x that are greater than or equal to negative 6. By the way, we can add here some arrows to point the positive direction of the number line. Under D, what do we get? We get x minus 2 is less than or equal to negative 3. Now we have to add 2 to both sides, so x is less than negative 1. Again, represented on the number line, it would look something like this. X is all numbers less than or equal to negative 1. Under E, we have 5 plus x is less than 3, so we will subtract 5, and we get 5 minus 3, it's negative 2. X is all real numbers that are less than negative 2. So that means to the left side of negative 2, like this, but negative 2 won't be included, so empty circle. And the last one, under F, we have negative x minus 1 is less than 6. We should add 1, so negative x is less than 7. Now we can clearly see we have negative x, meanwhile we want to have x is less than or x is greater than. Doesn't matter. So we multiply by negative 1, we get x is greater than negative 7. Because we multiplied by negative number, the sign from less than becomes greater than. Now this represented on the number line would look something like this. So from 7 and on, obviously 7 is not included in the solution. Graph the solution set of each inequality on a number line. Pretty much the same like previously. So under G, what do we have? We have 2x is less than or equal to 4. Well, if we just divide by 2, what do you get? X is less than 2, less than or equal to 2. And represented on the number line, it would look from negative infinity up to 2, including the number 2. Under h, we have 3x is less than negative 6. Divide both sides by 3, we get x is less than negative 2. And all x's less than negative 2 are represented on the left side of negative 2. Let's continue on I. We have negative 4x greater than or equal to 8. We can divide first by 4 and then by negative 1, but it's easier to just divide by negative 4. So x, now because negative 4 is a negative number, obviously, we will switch direction from greater than or equal to less than or equal. And 8 divided by negative 4, it's negative 2. Represented on the number line, this would be all x's less than negative 2, also including negative 2. And j, x over 3 is less than 1. Well, now we will have to multiply by 3 to get rid of the denominator here, 3. So we multiply both sides by 3. And what do we get? We get x is less than 3. Shown on the number line. It looks like this. And k, under k we have x over 2 is greater than or equal to 0. Multiply both sides by 2, we get x is greater than or equal to 0, because 0 times 2 is again 0. Shown on the number line, it would look from 0, all x's greater than or equal. Now if it says or equal, we should fill that circle there. And the last one, under L, it's negative x over 3 less than 1 over 2. Now if we multiply both sides by 2, we will get rid of the denominator. Both sides by 2, we will get rid of the denominator here, but we won't get rid of this one here. Same goes if we multiply by 3, but if we multiply by 6, we will get rid of both denominators. So what do we get? We can show step by step here. So we get negative 6 over 3 is less than or equal to 6 over 2. Now 6 over 3 it's 2, so negative 2x is less than 3. Now I just want to divide by negative 2. We could have directly multiplied only here by negative 3 and it would have been perfectly fine. Why not? So divide by negative 2, x would be now, instead of less than, it would be greater than negative 3 over 2. Shown on the number line, it would be negative 3 over 2, all x's that are greater than, or equal, which has been represented here. We will continue with exercise 4. Now it's asking only to solve this inequality, so it's not requiring us to represent it on the number line. So let's just solve this inequality. What do we have? 5 minus x is less than 7. Obviously, first we will subtract 5. So what's left? Negative x is less than 2. Then we multiply by negative 1. So we get x is greater than negative 2. That's it. We can leave this in an inequality form, or on a set form, it would be from negative 2 to infinity. Under b, 2x plus 1 is less than 5. We will subtract 1, so we get 2x is less than 4. Divide by 2, and we get x is less than 2. This is in an equality form, like set, it would be from infinity, from negative infinity up to 2, because 2 is not included, we will use a regular parenthesis. Under C, we get 3x minus 1 greater than or equal to 8. We will add 1 to both sides, so 3x is greater than or equal to 9. We will divide both sides by 3, so x is greater than or equal to 3. As a set, x is element from 3 to infinity, but now because 3 is included, we should use a square bracket. Under D, 2x minus 3 is less than 5. Let's add 3 to both sides. 2x is less than 8. Divide both sides by 2. X is less than 4. That makes x element from negative infinity up to 4, but including the number 4. Under E, we have negative 3x minus 7 is less than negative 1. So let's add 7 to both sides. Negative 3x is less than 6. Divide both sides by negative 3. Because we are dividing by a negative number, it switches direction from less than, it becomes greater than. 6 divided by negative 3, it's negative 2. As set, it would have been x from negative infinity up to negative 2, excluding negative 2. And the final one, f, negative 4x plus 1 is less than or equal to 9. We will subtract 1, so negative 4x is less than 8. We will divide both sides by negative 4, so what do we get? X is greater than or equal to negative 2. As a set form, it would be x from negative 2, including negative 2 up to infinity. And the fifth exercise, under A, we get 2x plus 3 less than x plus 1. We will subtract x from both sides, so we get x plus 3 less than 1. We will subtract 3 as well, so x is less than negative 2. B, 2x plus 3 is less than negative 5 plus 3x. We can subtract 2x here, so we get 3 is less than or equal to negative 5. Now 3x minus 2x is just x. Then we add 5 to get rid of this 5 here. We get 8 is less than or equal to x. We want to rewrite it on this direction like this, so x is greater than or equal to 8. Under C, we get 9 minus 2x is greater than 13 minus 6x. If we add 6x, what do we get? 6x minus 2x, that's 4x, plus 9 greater than 13. Now if we subtract 9, we get 4x is greater than 4. Divide both sides by 4. We get x is greater than 1. Under D, we have 12 minus 13x is greater than 15x minus 15. Alright, we can add 13x. Our goal is just to separate x's and terms that have x and the terms that don't have x on different sides. It really doesn't matter which side you pick. So it will be 12 is greater than or equal 15x. When added to 13x, it would be add up to 28x minus 15. We will add 15 to both sides, so 27 is greater than 28x. Divide both sides by 28 to leave x alone. We get 27 over 28 is greater than or equal to x. Just to write it in a more convenient way, 27 over 28. X must be less than 27 over 28. Alright, let's continue with E. Under E we have negative 2 in brackets x plus 1 is less than 4 minus x. Let's get rid of these brackets first. Negative 2x minus 2 is less than 4 minus x. We can add 4 to both, actually we can add 2x to both sides, and we get negative 2 is less than 4. Negative x plus 2x is just x. Then subtract 4, we get 4 minus 2 is 2 is less than or equal to x, which in a more convenient way would be written something like this. And the final one, 4 minus 3 times x minus 1 is less than negative 5. 4 minus, let's multiply, negative 3 times x, that's negative 3x. Now negative 3 times negative 1 is positive 3. And if we add up 4 and 3, that makes 7 minus 3x is less than negative 5. Subtract 7, we get negative 3x is less than negative 12. Divide both sides by negative 3, we get x is greater than or equal to 4. That was it for exercise 3. Let's continue. Exercise 6. 3x minus 2 over 2 is less than 2x plus 2. If we multiply both sides by 2, we will get rid of the denominator, and the rest would be just exactly like the previous exercise. So what do we have on the left side when we multiply by 2? 3x minus 2. Now right side multiplied by 2 means we'll multiply this term by 2 and this term by 2. So what do we get? 2x times 2, that makes it 4x plus 4. Right, now this exercise is just solvable like the previous ones. Minus 3x, so negative 2 is less than x plus 4. Now I subtract 4, so we get negative 6 is less than x. To write it in a more convenient way, something like this. Under B, we have 2 times x minus 3 over 5 is less than 3x plus 6. Again, we will multiply both sides by 5 to get rid of the denominator. So on the left side we have 2x minus 3 less than 3x multiplied by 5, it's 15x. 6 multiplied by 5, it's 30. Let's get rid of these brackets. So 2x minus 6 is less than 15x plus 30. We will subtract 2x. If just in case you want to perform two operations at the same time, we can subtract also 30. So what do we get on this side? Negative 6, negative 30. It will be negative 36. On the other side, 15 minus 2 makes 13x. Divide both sides by 13, and we get negative 36 over 13 is less than or equal to x, which we can rewrite it something like this. And let's continue with the last exercise from exercise 6, which is under C. We have 3 plus 2x minus 3x minus 1 over 2 is less than 3 plus 1 minus x over 2. If we multiply both sides by 2, we will get 3 times 2, that's 6, plus 2x times 2, that's 4x, minus 3x minus 1. If we leave it like this, it's a mistake because this negative 1 multiplies the whole expression here, so you should put it in brackets, is less than or equal to 6 plus 1 minus x. Alright, so we get 6 plus 4x negative times 3x, that's negative 3x. Negative times positive, negative 1 makes positive 1, is less than 6 plus 1 minus x. We can collect some like terms. 6 and 1 makes 7, 4x minus 3x. 4x minus 3x is just plus x is less than 7 minus x. Now if we subtract 7 from both sides, these two 7s will just cancel out, these two here. So we get x is less than negative x. If we add x to both sides, 2x is less than 0. Divide both sides by 2, we get x is less than 0 as well. Right. Next exercise. If we have some fractions but with different denominators, how would we solve these kind of problems? Well, pretty much the same as the previous exercise. We will just multiply by a number that will get rid of all these denominators. Those numbers, there are infinitely many of these numbers, but it's always better to multiply by the least common multiple of the denominators. In this case, 2, 5, and 10, the least common multiple would be 10. So we will multiply this fraction here by 10, this by 10, and this by 10. So what do you get? 10 over 2 is 5. 5, 1 minus 5x, plus 10 over 5, it's 2. 2 minus 2x is greater than 10 times 1. Alright, now let's get rid of these brackets. We have some like terms. These are like terms. Let's add them up. So 9 minus 29x is greater than 10. We will subtract 9. Negative 29x is greater than 1. Divide both sides by 29. Let's divide both sides directly by negative 29. So we get x is less than negative 1 over 29. And under E, we have x plus 1 over 8 plus x minus 1 over 3 is greater than or equal to 4x minus 3 over 12. Least common multiple of 8, 3, and 12 is 24. So multiply both sides by 24. What do you get? You get 24 over 8, that makes 3, so 3x plus 1, plus 24 over 3, that's 8x minus 1 from the second fraction. 24 over 12, that makes it 2, 4x minus 3. The same goes here. We get rid of these brackets, so expand those brackets. 3x plus 3 plus 8x minus 8 greater than 8x minus 6. 3x and 8x is 11x minus 5 is greater than 8x minus 6. We can perform two operations at the same time. Minus 8 from both sides plus 5. So to get rid of this 5 and this negative 8, to separate x's on one side and constants on the other side. So negative 11x minus 8x is just 3x is greater than negative 6 plus 3, that's negative 1. Divide both sides by 3, x is greater than negative 1 over 3. Solve each inequality and graph its solution on set of a number line. Well, the first one, it's just given, the solution is already given, like x is between 3 and 5, excluding 3, including 5. Let's just represent it on the number line. So we don't have to find all numbers here. It's enough just to find the important ones. So from 3 to 5, 3 is not included, 5 is included. But this is not the case under B. Under B, we don't have x given. We have x minus 5 given. So what would we do? We will add 5 to both sides. So 7 and 5, 2 and 5 makes 7. This makes 8. Alright, so x is between 7 and 8, excluding 7 and excluding 8. This doesn't mean there is no number. It means that there are these decimal numbers. It's not necessary for x to be an integer. Alright, under C, we get negative 5 is less than x plus 2 is less than 7. So we subtract 2. Actually, there are not two sides, there are 3 parts here. So we will subtract 2 from all sides here, and we get negative 5 minus 2, that's negative 7, is less than x, is less than 5. This one represented, it's something like this. So we have all x's from negative 7 to 5, excluding both of them. Then under D, we have 4 is less than 2 minus x, less than 6. If we subtract 2 from all sides, we get 2 is less than negative x is less than 4. So negative x is between 2 and 4. Now if you multiply by a negative 1, we get 2 is greater, negative 2 actually is greater than x is greater than negative 4. This is not a so convenient way, so let's flip direction for all of these. Negative 4 is less than x is less than negative 2. Shown on the number line, negative 4 is here, negative 2 is here, and x is all the numbers from negative 4 to negative 2, excluding both negative 4 and negative 2. Under E, we get 3 is less than 2x plus 1 is less than 5. So we subtract 1, 2 is less than 2x is less than 4. Divide both sides by 2. When you divide by a positive number, the signs are preserved. So we get an inequality like this. All numbers between 1 and 2, excluding both of them. And the last one, under F, we get negative 5 is less than 3x minus 2 is less than 7. So then we add 2 to both sides and we get negative 3 is less than 3x is less than 9. Divide both sides by 3 to get rid of this x. So negative 1 is less than x is less than 3. So represented on the number line, we have negative 1, we have 3 here. So from negative 1 up to 3. Now because negative 1 is included in the solution, it will be something like this, and 3 is excluded from the solution set. And we have some more exercises of the same type. Under G, we get 3 is less than 1 plus x over 3 is less than 4. Let's subtract 1 from both sides. 2 is less than x over 3 is less than 3. Multiply both sides by 3 to get rid of the denominator. So x is between 6 and 9, excluding both 6 and 9. Under H, Now that because we are involving now multiple x's on all sides, if you try to add an x to all three sides, or maybe try to subtract, you won't get rid of all those x's. So in order to solve this problem under H, what would we do? Well, we can separate this problem into two inequalities and merge the solutions. So the first inequality would be this one, and let's label it first one, and the second one here. So the first one, let's try to solve the first one. Add 2x to both sides. 3 is less than 3x plus 1. We will subtract 1. So 2 is less than 3x. Divide both sides by 3. 2 over 3 is less than x, which can be rewritten as x is greater than 2 over 3. This is the first part. And the second part would be these two inequalities here, like the second one and the third one. So you get x plus 1 is less than 2x plus 5. Now let's subtract an x, and we get 1 is less than x plus 5. We subtract again 5, so we get negative 4 is less than x, which can be written x is greater than negative 4. If we want to show these two inequalities on the number line, let's see, negative 4 is here, and x is 2 over 3. So the first inequality, this one, let's use a black color for that region. It says all x's that are greater than 2 over 3, which are these x's, but excluding 2 over 3. We will use another color, let's pick purple for the second part, which is x is greater than negative 4. Also, it's excluded. Now, our solution set would be all x's that fulfill both conditions. So it's practically this brown part, which means we can rewrite it in terms of inequalities. We can write it x greater than 2 over 3, or in terms of sets we can write it as x from 2 over 3 to infinity, like this. Let's continue solving exercise I. On this exercise we can use the previous method. Sometimes it happens that if you just add x, you will get 2 is less than 6 plus x is less than 4. Now we got rid of these x's on these two inequalities here. It may happen sometimes, rarely. Now we can subtract 6, negative 4, negative 2. So x is between negative 4 and negative 2. This was under I. And under J, we have 2 over 3 is less than or equal to x plus 1 over 4, which is 2x plus 1 over 6. If we multiply both sides by 12, we will get 12 over 3, 4 times 2, 8. 3x plus 1 to 2x plus 1. So that makes it 3x plus 3, 4x plus 1. This inequality is also solvable the same way as we used on exercise under H. We will have to separate it into two inequalities. Let's use the first inequality. 8 is less than 3x, actually less than or equal to 3x plus 3. 5 is less than 3x after subtracting 3. Now dividing by 3, we get x is greater than or equal to 5 over 3. For the second part, we get 3x plus 3 is less than 4x plus 1. Subtracting 3x and subtracting 1, we get 2 is less than x, which makes x is greater than 2. We can represent it here on our number line as 5 over 3 and 2. 5 over 3 is less than 2, so it will be on the left side. The blue side of this equation, the first one is all x's that are greater than 5 over 3, including 5 over 3. The purple part is all x's that are greater than 2 but excluding 2. So the common region would be this region here, which makes x greater than 2. And the last exercise for today is the 8th one. Let's multiply the bracket so we get x times x. X times x is just x squared. X times 3, 3x. 2 times x, 2x. 2 times 3 is 6. Well, get rid of brackets on the right side. X times x, x squared minus 3x plus x minus 3. Subtract x squared from both sides. We just cancel these. And on the right side, what do we have? We have 5x plus 6 is greater than negative 2x plus 3. Add 2x. We get 7x plus 6 is greater than 3. Subtract 6. 7x is greater than negative 3. Divide both sides by 7 and we get x is greater than or equal to negative 3 over 7. That was it for today's video. See you another time.